Okay, now let's look at an example. So odd number of NOT gate or inverters are connected in feedback. You can say 3, 4, 5. Now it's called as ring oscillator. We will see more about ring oscillator later on. Okay, when we will see the sequential circuits. TPD is given for each of them. It's 100 picoseconds, and you have to find the frequency of the output signal here. Okay, so it's simple. You can see. So the time frequency will be inverse of time. The time period will be equal to 2n TPD, 2 into 5, 3, 4, 5 into 100 picoseconds. Okay, so F will be equal to 1 upon this T, that is 2 into 5 into 100 picoseconds, and this will give you 10 to the power 9 hertz. Okay, or you can write it in this fashion as well, megahertz, or F is equal to 1 gigahertz. This will be the answer. Okay, just one extra point, you can also include that F is equal to 1 by T, and you can apply it. Simple example. Okay, now let's look at another example. Here it is given 3 of the inverters are connected in feedback, but there is an extra inverter which is not in feedback. So each of the NOT gates are having propagation delay of 2 nanoseconds. Time period of this signal at the output of this NOT gate we have to calculate, and of the generated wave here. Okay, so what will be the approach? So this part of the circuit we know already. So it's a stable multivibrator. Okay, so we can calculate the signal here. So I'll call it as output 1, and here I'll call it as output 2. Okay, so now what can happen? We can calculate the time period of the output 1, which is just the time period will be 2 into n into TPD. N is 3, 2 into 3 into 2 nanoseconds. Each of them are having 2 nanoseconds. 3 to the 6, 6 to the 12 nanosecond. So this output 1 will be a square wave of 12 nanoseconds time period. Okay, how it will look? This is how it will look, and this will be a square wave, and the time period will be this 12 nanoseconds. This is how your output 1 will look like. Now what will be this NOT gate will do? Inverter, it will just shift it by 2 nanoseconds. Okay, nothing change. It's not in feedback, it's not a part of feedback. So NOT gate will shift it plus invert it. Okay, so how it will look? So first I'll make the unshifted version, then I'll shift it. So unshifted version will be, since it is 1, it will be 0, then 1, since it is 0, likewise it will go. Okay, so output, this is output 2 without shift. Okay, without shift, and now there is a propagation delay of 2 nanoseconds. So this waveform you just shift it by 2 nanoseconds. So I'll make here, so this I'll make the lines so that you will be clearly visible. Okay, so here if you will see, so this one will be 0, but there will be a 2 nanosecond delay before it changes state, then again like this, like this, like this, like this. So it's the same signal, this signal, but here you can see there is a delay of 2 nanoseconds because of the propagation delay of this NOT gate. Okay, so there is a shift, the same signal shifted, and because there is a NOT gate, there is an inversion as well between output 1 and output 2. So this is output 2 with shift. Okay, with shift. So this is the answer. This is how the signal will look like, and the time period will again be 12 nanoseconds. So it is just a shifted version, inverted and shifted version of the output 1. So time period won't change because whole signal is shifting. Okay, there is no single part of the signal is shifting. All the signal is whole signal is getting shifted by 2 nanoseconds from here to here. Okay, here to here. That's why the time period will be intact, 12 nanoseconds. This is the answer.